Question number 30. The figure above shows a regular hexagon with sides of length A and square of sides length A. So all of these sides right here are of length A on both the hexagon and the square. If the area of the hexagon is this, then what is the area of the square? Well, if you start with the area of the hexagon is this, what I would enjoy doing here is dividing it up into 12 pieces. You could, I didn't draw them out, but there are 12 triangles, 2 for each of the 6 sides. There's another one over right here. And if you do that, then what you find is that you get a 30, 60, 90 triangle. And we have lots of properties that talk about what 30, 60, 90 triangles can do, particularly ones that have square roots of 3. That's actually what cued me off. If you have an answer that has square root of 3, look for the 30, 60, 90 triangles because of this fact right here. The shorter leg of a 30, 60, 90 triangle, that's in this, it would be the height, the h, times the square root of 3 is going to equal the longer leg right here. That's a property of 30, 60, 90 triangles, and so that's what cued me off. This square root of 3 motivated me to find the 30, 60, 90 triangle, and here it is. I divided it all into 12 pieces. So, translating the variables, we get h, instead of the short leg, it's h, instead of the long leg, it's b. Instead of the area of the height, instead of the area of the hexagon, you could divide it up by 12, and the area of the hexagon divided by 12 is just the area of the 1 30, 60, 90 triangle. 384 divided by 12 is 32. And so we get the area of the triangle is equal to 32 square root of 3. And the formula for area of the triangle is 1/2 base times height. Now we know that if this were just a formula with just one variable, then we could solve it really easily. But we've got 2 variables. So we have to use this relationship to substitute. I'm not going to write b anymore. I'm going to write instead h times square root of 3. And here it is. This is the 32 square root of 3 equals 1/2, not base, but h times square root of 3 times the height, this height and this height. And the rest of it is solving the equation. You can multiply both sides by 2 to clear the fraction. You get 64. You can take this h and say it's h squared. You can divide both sides by square root of 3 to get 64 is equal to h squared. And therefore, taking the square root of both sides, you get 8. Algebraically, you could get -8 when you take the square root of both sides, but because it's geometry and an actual length, then we're not going to have negative 8 inches as a height. So here we've got h as the 8 is this. This is 8 inches long right here. If you want it in terms of the square, what that means is the side of the length of the square is 8 times 2. There's 2 of these, which would give you 16. And if you want to find the area of the square, you square the sides. 16 times 16 is 256, and that's the answer.